Hi, welcome back. In this short video, I'm going to review the derivatives of functions involving logarithms. Just like in the previous case where for computing derivatives of exponential functions we have two formulas, here also we have two formulas. One of them is if y equals ln x, ln is the natural log of x, then dy by dx is 1 over x, and this formula is true when x is positive. Okay? So really, of course, x will be positive because ln x is defined, and as you may recall from pre-calculus, this x has to be positive. That's one formula. What happens if y is not simply x, a function of x, ln of a function of x? How does the derivative change? In this case, dy by dx is, you write this f of x in the denominator. In the top or in the numerator, you have f prime of x. Here f prime is the derivative of the function f of x. These are the two formulas that are useful in differentiating functions involving logarithms. Now let's take a look at a couple of examples here. So example 1. My function is y equals natural log of 8x minus 4. Here the understanding is everything is defined. That means this is a positive thing. You really don't need to worry about that. You just have to apply the formulas. Which one should you apply? If you look at here, it's not simply x, it's a function of x. Usually that will be the case. Therefore, you have to apply formula number 2. So dy by dx is, like I said, you write 8x minus 4 in the denominator, 8x minus 4, and in the numerator, if you want, you can write this as x minus 4 prime. Remember, prime for us is the derivative, not the first power. This is the derivative of 8x minus 4. Now let's differentiate 8x minus 4. Derivative of 8x is 8 times derivative of x, which is 8, which is 1. So 8x derivative is 8. Derivative of 4 is, 4 being a constant, it is 0. So you have 8 by 8x minus 4. In the book, it might be a little bit different. They might say this is 8 over, if you take 4 as a common factor between them, it is 2x minus 1. Now cancel 4 in 8. So it's really 2 over 2x minus 1. That could be your final answer. Okay? Let's look at another example. Maybe I'm going to erase this. Ln of 1 plus x quantity cubed. Here, when it comes to logs, there are some interesting formulas that you could use to simplify before you could find the derivatives. So for example, if you have a stuff inside to the third power as an exponent, the exponent comes out. That's one of the properties of basic properties of logs. you must have learned in pre-calculus. If you don't remember that, still you could compute the derivative, but it takes a little bit longer and more effort. So let me show you how you could apply the properties of logs to differentiate this function in a simpler way. So I'm going to use the properties of logs, and the property is if ln of x to the power of m, it is same as m times ln x. This is one of the properties of logs I'm going to apply here. So this 3 is like m up there. So 3 comes out, so it's 3 times natural log of 1 plus x. So I have not done anything except for simplifying the function. So now my function is y equals 3 times ln 1 plus x. Now it's a constant times the function, and as we have learned in the first unit, keep the constant and differentiate the function. In this case, we have to apply formula 2. Most of the times you'll be applying formula 2. So dy by dx equals 3 times, you write that function 1 plus x in the denominator, and in the numerator 1 plus x prime. And this prime means the derivative. So if you write it this way, even if you made a slight mistake in differentiating the function, you get some partial credit. So that's why I suggest you to simply write the function, and in the numerator write the notation for the derivative. Now we're ready to differentiate. 3 times, what's the derivative of 1? Here we're applying sum rule. Derivative of 1 is 0, plus derivative of x is 1, divided by 1 plus x. That's it, we're done with the derivative. So it's 3 times 0 plus 1 is 1, so it's 3 over 1 plus x. And that's the answer for this. Okay? Let's try one more problem. Okay? Let me erase this. This time, my function is y equals ln x to the power of 4 plus 5x squared to the power of 3 halves. That's my function. So again, it looks like this. You have something and the power. Something to the power. So I'm going to apply that property to pull this 3 halves up to the front. So this is same as 3 halves times ln x to the power of 4 plus 5x squared. If you don't apply this property of logs, the process will be a lot more complicated. Now we're ready to differentiate the function. So compute dy by dx. So dy by dx of this. 3 halves is a constant, so you set aside. Compute the derivative of the function, ln. And again, we're going to use formula 2 here. So write down the expression in the denominator, x to the power of 4 divided by 5x squared. In the top, as I said, x to the power of 4 plus 5x squared prime. And prime stands for the derivative. Okay? Now let's compute that. So 3 halves times, what's the derivative of x to the power of 4? It's a power rule. It's 4 times x cubed plus, set aside the constant and differentiate the function x squared. X squared derivative is 2x, so it's 10x divided by x to the power of 4 plus 5x squared. So if you multiply out 3 times 4x cubed plus 10x divided by 2 times x to the power of 4 plus 5x squared. If you cancel out 2 in each of these, the answer would be 6x cubed plus 15x divided by x to the power of 4 plus 5x squared. Okay, that's the answer. Thank you.